Yes, we're going to be going back to the Miro platform, Miro, you know, charts. I'm going to present the entire board. If you remember from one of my previous videos where I talked about thinking, I presented different mental models for thinking: experimental thinking, systematic thinking, first principles thinking, axiomatic thinking. And all of that was just a guide to get people to really think about their own thinking, right? It's this idea that we need to start, reclaiming our own, as corny as it sounds, but we want to reclaim our own power to thinking. We don't just want to, we don't just want people to tell us how to think or to how to learn a particular subject in a specific way. This is a little bit of a spoiler alert, but today we're not going to be talking about this. We're going to be talking about this. We talked about how to think in one of my previous videos, and I think it was my second video in this YouTube channel. And the video after that, I talked about how I would learn AI in 2025, and how I'm actually personally learning AI in 2025. But there's a lot of buzz, there's a lot of noise, there's just a lot of noise. There's so much hype and so many tools out there. And this is exactly why I created the videos that I created on how to think, so we can filter out that noise. And this method is actually the same exact method that I use to cut out the noise on so many YouTube channels out there that just are really just people that are selling you tools or AI tools, which is fine, there's nothing wrong with that, but it's just so much noise, it just doesn't help. It just really doesn't help. There are only very few channels out there that I highly recommend for learning AI engineering. One of those channels I would probably say, I'm terrible at pronouncing names, Dave I can't pronounce his last name, I'm sorry, but I'll probably show it somewhere in the video. Just search up a video called AI Agents Without the Hype. It's an amazing channel right there, because the dude has a data science background, so he actually understands these things from first principles, right? What I was talking about here in one of my videos, first principles thinking. So I'm just gonna, right at the bat, I am not an expert in AI agents. I have a data science background, but it doesn't necessarily mean that therefore I know everything about AI. No. And that's exactly what I'm gonna be talking about today, for anyone who wants to get into this game. And that's the thing, it's a game. We have to see it as a game. The question is, what game are we playing, right? So, first of all, this flowchart right here, we're not going to be talking about today, and neither are we going to be talking about that. I already talked about that in my previous videos, and I check out my previous video where I talked about how I learned software, AI engineering in 2025. Here I'm going to be going deeper into that and kind of sharing what I'm already doing. So this is kind of like my plan that I'm already executing. One of the reasons why I haven't been able to upload, because I've been very busy with this, and yeah, so I just want to share and see what you guys think about it. The way I like to learn things is very unorthodox. First question, what is intelligence? Yeah, this is the question that we need to start off with. First of all, before we actually understand the game that we're actually playing, the whole AI game that we're playing, we first need to understand what intelligence is. Now, here's the thing, nobody knows what intelligence is. Why? Because intelligence, my friend, is something that is tied to an even more fundamental concept in philosophy known as consciousness, and nobody knows what consciousness is. Nobody understands what consciousness really is. Everyone has theories out there on consciousness, but just no one, it's hard. It's hard to define consciousness, really, because it's just the hardest problem of all sciences. The hard problem of consciousness, look it up. I don't want to dive into that rabbit hole here, but just to be, quick, it's tied to intelligence. This is why intelligence is not an easy thing to define. Also, because the field of psychology is a relatively new field, and some people would say it's not really science, and some people would say, no, it is a science. I'm not going to get into that. But intelligence has many theories. Number one, there's Gardner's theory of multiple intelligence. You got your visual, spatial, linguistic, verbal, logical, mathematical, body kinesthetic, musical, interpersonal, naturalistic, right? So I would also add to that like philosophical intelligence. So we got people that are like very good at, or very social. They're very good at like socializing with others. We got people that are like very, maybe not so social, but they're very good. They have a lot of introspection, right? They understand themselves very well. And there are people that like are just really good with their bodies, right? Body kinesthetic intelligence, for example. They are like amazing. A lot of these people end up becoming athletes, martial artists, things like that. Logical, mathematical. This is one of the reasons why maybe someone who's like a physicist or a scientist or a mathematician do not have the same mindset that a philosopher has, right? You would think that a physicist, like if you ask a physicist what the meaning to life is, they would be able to answer that question for you, but sometimes they lack a lot of philosophical thinking, and that's where philosophical intelligence comes into play, or existential intelligence, which in some versions of Gardner's theory it's included there. Here I didn't include it because I forgot, but just something to look up in your free time if you want. Next is fluid intelligence. So instead of having this idea of multiple intelligence as multiple intelligence, is pretty self-explanatory, right? We focus only on verbal expression, working memory, processing speed, and reasoning. In other words, we focus more on the capacity or your cognitive power, basically. And this is what IQ tests tend or try to measure. I have my personal critiques on IQ tests. I think that they're very limited, and I feel like a lot of them focus a lot like on mathematical intelligence, like logical mathematical intelligence. I feel like that's a problem as well. But anyway, crystallized intelligence. Crystallized intelligence is not really an intelligence, but an important factor to intelligence. It's how much stuff you know. That's all it is, just your knowledge. Or in machine learning, it's the data the model has. So if we were to, visualize ourselves as an AI model, AI cannot work without data, right? So you need data. The more data you have, the better. So if computing power would be your fluid intelligence, then crystallized intelligence would be the data that you feed into a machine learning model, if we were to visualize ourselves as an AI or as a machine learning model. And some machine learning models are very good for certain tasks, right? Other machine learning models are better for computer vision. Other machine learning models are better for natural language processing. Same thing for like Gardner. This is how kind of like related to human beings in Gardner's theory of multiple intelligence. Some human beings are very good for body kinesthetic related tasks, like becoming athletes and that kind of stuff. Other human beings are very good at naturalistic intelligence. They just have this connection with nature. And they all have something in common. They all have data, because data they collected throughout their lives from the time they were born, and through practice and engaging in a particular task, right? Training. If you're in the machine learning game, training a machine learning model or an AI model, right? They train, they practice. Or it could also be installed into genetics, similar to an AI model like ChatGPT, for example. GPT stands for Generative Pre-trained Transformer. It's a pre-trained model, right? So I kind of like to make those analogies when it comes to intelligence. Now here's a very practical yet simple definition on intelligence. Rate of learning. Same condition, new behavior. And I got this definition from this business YouTuber called Alex Hormozi. I love this definition because it's very simple and practical. So while the other ones are more academic, this one's very practical. It's just same condition and new behavior. It also relates to machine learning, really. Imagine I'm trying to learn how to juggle a ball, right? Juggle a soccer ball. And what is easier, to learn that skill by myself or with a coach that already knows how to juggle a soccer ball? Well, the difference is a coach that knows how to juggle a soccer ball can give you something very unique, which is called feedback. So you are at a soccer field, for example, you have your ball is probably a size 5 soccer ball, and those are all the conditions, and the weather conditions is not very windy, the temperature is fine, so we got the exact same condition. So we have a specific condition. And the behavior, the ideal behavior that you want is you to be able to, keep the ball in the air for, or in soccer you call it keep-ups, I believe. You want to be able to do 100 keep-ups, right? Keep the ball up in the air 100 times. Kicking the ball up, right? Or kick-ups. That is the desired behavior, or the desired outcome. Now, in the beginning, you are going to drop the ball. You're going to go on the ground. It's just gonna roll over and whatnot. You're gonna be very frustrated. So there are certain things that you're doing that's wrong, that if you were to continue repeating, you're just going to continue failing, and you're never going to reach that end outcome. You have to change your behavior under those same conditions, right? And a coach can really help you change your behavior in a way that can increase the chances that you get to that desired outcome that you want. And this applies to almost anything. So it's a very practical definition. I'm not going to get into that. You could, search it up, same condition, new behavior, and type in Alex Hormozi. It's very practical. But an even better definition of intelligence, in my opinion, that's just super practical, is focus. How focused are you? Someone who's a genius has an IQ of 165, for example, and someone who literally says no to everything, because that's how you define focus. Focus is just your ability to say no to things, to everything, really. Like, you being able to say no to everything else, by definition, is you only doing the one thing that matters. So if I want to be focused on writing, for example, then I have to say no to everything else that is not related to writing, or to the task of me writing an essay, for example. And the problem with focus is yes, it could be a cognitive problem, obviously, but it's more of your lack. It's not your ability to focus. It's not this thing that you just have to push through. No, it's your lack of ability of saying no to things, right? So if I am, for example, being distracted by, if this TV behind me, this is a TV by the way, was on, and there was a live football match, and when I say football, I'm talking about soccer, because that's my definition of football. Football is soccer. I don't think about touch football, but anyways, if there was a football match live, I would be very distracted. If there were people around me that were talking, I would also be very distracted. If I have Instagram on, social media and whatnot, I'm not saying no to those things. And in me not saying no to those things, I'm obviously going to be distracted. Now, this sounds kind of obvious, right? But we really don't know how to say no, right? We just really don't. It sounds obvious, but we just don't know how to. And the reason for that is because, well, number one, we underestimate heavily how distracted we can get when we just don't say no to things. And saying no to things, it's not just about it's not something just physical. It's not just putting boundaries or limits with people. That's also a thing, but it's also about being very minimalistic. Try to be as minimalistic as possible. How many objects do you have in your table, for example? Is that distracting you? For some people, it might not be distracting. For others, it could be very distracting. The only thing I have in front of me right now is my glasses, my keyboard, my mouse, this microphone, the case for my glasses, and a notebook, and this phone, because I have a script in here that I'm also following. But even if you go to my phone, I actually have it extremely minimalistic, very minimalistic. I installed this app called Minimalist, I believe, because I understand I truly understand the power that colors that a lot of these apps have over your brain. They stimulate your brain. They produce dopamine. You cannot. I think the main problem is we really underestimate the power of how these devices can distract us. We truly we know in theory that yes, they distract us, but we don't really take it seriously. We don't take it seriously enough to maybe you don't even have to install the Minimalist app. You don't. I'm not endorsing it or anything, or I'm not no. I'm just saying you can actually instead go to settings and just make your phone black and white. That's also pretty effective. I just like to go to the extreme and make things super minimalistic. It helps me. It helps my brain. Also turn off all notifications, delete a bunch of apps. That is also that's also saying no to things. Deleting apps is saying no to things. Setting boundaries. Saying no to certain people, or maybe like stop going out with or surrounding yourself with a certain group of people. That is also an important skill that increases your focus. And when you can increase your focus, you increase your intelligence, because it increases the rate at which you change your behavior under certain conditions, right? Same condition, you need behavior. And this requires a lot of energy, and that's the problem. If I am focused on a task and I have notifications coming everywhere and I have people interrupting me all the time, the amount of energy your brain is exerting, like you're wasting just a bunch of energy. It's like you have this like balloon full of water and you're just poking holes in that balloon. Each distraction is a needle, breaking into the balloon, and it's just like deteriorating the entire balloon. And all of a sudden you're depleted of energy and you no longer want to do anything. Well, duh, because all your energy was supposed to be funneled through into the task that you were focusing on. Notifications that are coming in are poking holes into that pipeline of focus energy that is being concentrated into the task at hand. And it's very, very important that we be very, very mindful about that, but like super mindful, if we actually want to make significant progress. Now, that's my little TED Talk on intelligence. Moving on. Here's how I define intelligence in relation to artificial intelligence, to AI. Because after all, we're talking about AI. Something that desires to expand its field of awareness and has a capacity to do so is what we call intelligence. What the heck do I mean? So, that's how I define it. First, let's break things down. Artificial. I'm getting very quasi-philosophical here, and the way I'm defining things is not very mathematical. I know that if you're in data science or machine learning, there's more technical ways to define it, but this is like a down-to-earth way, / not so down-to-earth, but also philosophical way that I like to define intelligence. Artificial intelligence, sorry. So first let's define artificial. Artificial is just something that is fake, or mimicking something real, right? That's all artificial is. It's just mimicking something that is real, or it is true, or something that is just fake. So what is intelligence? Intelligence is something that desires to expand its field of awareness and has a capacity to do so. Something that is conscious of its own existence, or is aware of its own existence, right? Getting back to that concept of consciousness, right? Something that's just aware of its own existence. Like if this mouse right here was aware of its own existence, it's going to have some kind of desire to expand its field of awareness. Now, what do I mean by field of awareness? All I'm saying is that every single life or thing that has aware of its own existence has this intrinsic will to life, or philosophers might call it the will to power, or the will to life, right? It doesn't matter. Point is, every single living thing has this, or some people might even call it survival instinct. You can call it whatever, you can label it whatever. Survival instinct, will to power, will to life. The point is, it's the same pattern. It's this desire to conquer, or to inhabit, or to mark its own territory, or to occupy space, right? It has that desire. Whether it has a capacity to fulfill that desire is another question. And that capacity is what I call intelligence. Now, this is a very abstract way of defining intelligence, and it's not very practical. If you want something more practical, then take a look at these definitions, which is why I presented it in the first place. But something that is more abstract, that connects into a concept that is even more abstract, which is AI. That is how I like to define things. And how I like to define artificial, well, artificial is pretty straightforward, just something that is fake or mimicking something real. Now, if we combine the two, right, artificial intelligence, that which is not conscious, and thus mimicking the desire to expand its field of awareness, and seems to have the capacity to expand its fake field of awareness, is what we call artificial intelligence. So, again, that which is probably not conscious. So we don't know. I mean, we do know. Like, nobody really believes that ChatGPT is aware of its own existence. People that really don't understand how ChatGPT works think that our ChatGPT has consciousness. But just for the sake of objectivity, I say that which is probably not consciousness, most likely not conscious. But of course, in the future, that could also be very debatable, right? I don't think it could ever get to a point where we can really create consciousness. But again, just for the sake of argument, I'm just gonna say that which is probably not conscious, and therefore has a fake desire to expand its field of work. It just seems that way, right? That's why sometimes we define artificial intelligence as that which mimics human intelligence. Another way to define AI if you want. But this is just me getting into the granular definition. Because if you say, okay, mimics human intelligence, the next question is, okay, what is intelligence? So that's why I wanted to start off with that question. What is intelligence? So that's what artificial intelligence is. Next question is, what is the game that we're playing, right? I mentioned in the beginning, what game are we actually playing? Okay, so moving on. 3 things that we need to get across. 1 is the how of AI, 2 is the what of AI, and 3 is the why of AI. And this is what we need to understand, because it's one thing, like, all these guys out there that are telling you, okay, make money with AI, do this with AI, that is a completely different niche as to the YouTube channels out there that are teaching you data science, for example, or machine learning, or diving into the mathematics of machine learning, or, you know, coding a transformer or a neural network from scratch. That's probably more the how of AI. And then there are the YouTube channels out there that are talking about, like, okay, is AI conscious or not? Or how do we know if AI becomes conscious or self-aware? There are channels out there that are talking about, like, you know, the future of AI, and a perfect example would be like the YouTube channel called David Shapiro, for example. He talks about philosophy. So that's the why of AI. Why do we do AI? And also a little bit of, like, what is AI, right? Which I would argue is a combination of cognitive science, philosophy, and physics. So all these fields, these 3 categories, are like what encompass everything related to AI, right? Obviously, you know, your AI bros out there that are trying to make money with AI, that's more on the how of AI, but mixed in with business, right? Get into, but I don't want to be like that bro that is just, like, you know, selling you a bunch of tools. I actually want to dig deeper into these tools, understand the how of these tools, using first principles thinking, and actually implement and build a useful project from it. So let's take a look at each of these, right? Let's take a look at, let's start off with the how of AI. So the how of AI can be summarized into 2 fundamental pillars, mathematics and computer science. Now, here is the map of, now, this is not my map. This is a map that I got from this YouTube channel called The Domain of Science. Amazing YouTube channel. Highly recommend his YouTube channel. This is maps. Very, very useful. I highly recommend that you get one of these maps. Yeah. So this is like what he calls the donut of knowledge. And this is, I don't know, I just find this map kind of useful. It kind of encompasses pretty much all of human knowledge. Obviously, we can locate AI, or the how of AI, here in computer science and mathematics. So if we were to, like, zoom in, hypothetically, into the map of computer science and mathematics, the beautiful thing about human knowledge is that the more you zoom in into a particular field, you're going to find another huge map connecting a bunch of other fields of knowledge, which I just find fascinating. It's like no matter how much you learn, there's always something out there that, you know, you just can't stop learning. And if we were to zoom into the map of computer science, again, this map is not mine, this is from the YouTube channel Domain of Science. Right here, that's his logo, you can check him out. I just wanted to share it. We got even more areas. We got theoretical computer science, computer engineering, we got all these different fields that you can get into, basically. Of course, this is actually pretty helpful, but it still doesn't answer the question, okay, where do I navigate? Where do I even start? It's good to, like, see the map and locate yourself, but it's not, like, practical for, like, okay, where do I actually even begin? Now, if we go into the what of AI, we get into, like, the hard problem of consciousness. And if we define the hard problem of consciousness that I talked about earlier, the hard problem of consciousness is the problem of explaining the relationship between physical phenomena, such as brain processes and experiences, i.e. phenomenal consciousness or mental states/events with phenomenal qualities, or qualia. What the heck does that mean? So qualia is just those internal, introspective, like, experiences that are happening in your mind, right? So the taste of an apple, right? How do we link the taste of an apple with the physical processes that are happening in your brain, right? No one can actually answer that question. We can probably causally explain how one thing leads to the next, or not causally, but we could probably explain correlations, or how this process leads to that process in the nerves, and these nerves leads to the feeling of touch, but we still haven't bridged the gap between the feeling of touch and the nerves, if that makes any sense. Or the signal, right? The brain sends a signal to, like, you know, when you touch something or you taste something, it sends a signal to your brain. Okay, that sends a signal. It still doesn't bridge the gap between the actual feeling that was produced to the physical processes, right? It still doesn't explain that introspective phenomena, or this just self-awareness or awareness of my own existence. It just doesn't explain that. Yeah, this is just a definition of qualia. Philosophers often use the term qualia to refer to the introspective, accessible, phenomenal aspects of our mental lives. And these are the sources that you can just check out. But yeah, not going to dive too deep into that, but pretty interesting stuff. Now, if we get into the why of AI, now we can understand the type of game we're playing. So why AI in the first place? Why are we doing AI, right? So what game are we actually playing? How can we navigate this entire map out here, right? This computer science map, which is really just the how of AI, because, you know, there's also the what of AI, so you might even want to dive into like cognitive science or something. How do we navigate this game of AI? How do we even define the game? And the reason why I call it a game is because, well, first of all, if I were to tell you soccer is a game. Very easy. If I were to ask you, like, hey, I want you to become the best soccer player that you can possibly be, it's pretty self-explanatory what soccer is. You know how to define the game. You know what the purpose, the objective of soccer is. You know the rules of soccer. It's very enclosed, right? It's very predictable. Same thing with basketball or another sport, or even a video game. It's like there's a set of rules that you need to follow, a particular environment, certain conditions, and a particular objective. So it's very self-explanatory. And it's very easy to measure how good you are. But there are certain fields out there that are not so easy to measure because they're very, one, they're constantly evolving, and two, it gets jumbled up with other fields, with other games. We lack the rate at which these fields evolve and change over time is faster than the vocabulary that we need to expand in order to define these games in the first place. And what do I mean by this? Take the question, for example, how do I become a top 1% programmer? I find that question funny because nobody really knows how to define programmer, the difference between programming, coding, and being a software engineer. And just the other day, I actually Googled that question, how to become a top 1% programmer. And everyone, like, agreed. It's like, okay, what do you mean by that? Like, actually, what do you mean by that? Do you mean, like, how do we even begin to define what a good programmer looks like? I mean, I guess we have some kind of idea, right? Someone that's really, like, good at coding, but what do we mean by really good at coding? Because some people might claim that a good software engineer is a person that can really, really solve problems and that can add value to a specific market. So they're looking at more of a business perspective. They're looking at more from like a business value perspective. Of course, if you want to, define value, there are ways to define value. Check out the value equation. And then you could really measure value, and then you could say, really the best way to measure if some software is valuable or not is how many users are you actually getting? How many people are actually using it? And, customer satisfaction, business concepts, basically. Because you can be an amazing programmer, but if you build something that nobody wants, then by definition, if you're defining things from a business perspective, then you're not a good programmer or a software engineer. Okay, there's a difference there, because there's coding, the individual that is very good at, like, maybe answering lead code questions, or data structures and algorithms, or maybe just understands syntax in and out. And then there's the player that is a programmer who understands syntax but is also able to build stuff. You tell them to build something and they'll build it for you. But then there's a software engineer. An engineer. The key word is engineer. An engineer is able to not just build whatever you tell him to build, or her, but is also able to think or understand if what I'm building is actually going to be valuable. In other words, they have a business-oriented mindset. So the question is, what game are you playing? Are you playing the lead code syntax game, or like the computer science or theoretical computer science game, where you're going into like the hard theory of coding and syntax and computer science and going deep into operating systems and that kind of stuff. Is that the game you're playing? That's fine. But just understand the game you're playing. And that game that you're playing won't necessarily mean you're going to become rich and, and build the next Apple. There are examples of people that have become rich in that field, yes, but in a different industry and different times. Now we're in different times, so it's going to be different. But don't expect to become rich if that's not your goal, which is fine. Again, what game are you playing? That's a real question. Are you doing it for the arts? In other words, are you playing the programming game where you don't care about the money, you don't care about any of any of that stuff. You just like building stuff, right? You just like building software. Great, that's fine. Then that's the game you're playing. You want to become a good programmer. You want to be able to get to a point where someone gives you a difficult problem and you solve it, right? If that's how you want to define value or, being a good programmer, then hackathons, for example, is probably a good way to measure a programmer's ability. But if you want to become a software engineer, an engineer by definition, someone who solves problems or adds value, and value is business value, where we define value as through the value equation, which I'm going to look it up right now. Value equation. Value equation, which is from Alex Hormozi's 100 Million Offers, I believe, or a book on 100 Million's offer. Dream outcome multiplied by perceived likelihood of achievement, all of that divided by time delay multiplied by effort and sacrifice. That is a value equation, right? So, if the longer you take, so the longer the time delay, the less valuable it is. The more effort and sacrifice the user has to make, the less valuable it is. The less effort and sacrifice or time delay they make, or both, ideally, the more valuable it is. If it gets to their dream outcome, the more valuable it is. If the user has a high perceived likelihood of achievement, the more valuable that it is. So that's how we can measure value, and that's how we could use this equation for reasoning through seeing if the software, the thing that I'm making or building is actually valuable or not. Of course, the ultimate test to do that is through market test, or see if we actually getting users. If that's the game you're playing, in other words, you're playing the tech entrepreneur game, which is very tied to the software engineering game, then it's really not that trivial, not that hard to measure value. It's really just how much money is your software making. If your software is making a lot of money, it's probably because it's solving a very high demand problem. And if you're solving a very high demand problem, by definition, you're a very good software engineer, because you're an engineer in the software space. That's it. That's a game. That's a business game. So you just have to understand what is the type of game that you're actually trying to play. Now, when it comes to that, that's why I'm very into how do we what game are we actually playing. Now, in the game of AI, you also have to, I'll get into that later, the game of AI in relation to coding, programming, and software engineering, and even data science. But first, let's try to understand just the broad view of AI. So, the game that we're playing in AI is the game of automation and prediction. That is it. That's the game you're playing. If you don't like those two words, automation, prediction, don't get into the game. What is prediction? Prediction is just approximating reality. That's all prediction is. Prediction is not just about, predicting the future or, approximating the future. Now, prediction is also approximating the past or approximating the present. When you build a machine learning model that can classify images of cats and dogs, it's not predicting the future, but it's still making a prediction. It's predicting whether the image that it's classifying, or that it's looking at is, it's predicting whether if it's a dog or a cat. That's what it's doing. It's approximating reality in the present moment. But of course, you can also use AI to approximate the past. I think for any of you who are in the Christian community or Catholic, and you heard of recent news about the Shroud of Turin, it's just for those of you who are not Catholic or Christian, it's just archaeological nerdy theology stuff, right? And they apparently used AI to find patterns in the Shroud of Turin. So the Shroud of Turin is basically this a shroud that just shows the kind of it's imprinted. It has the face of Jesus imprinted, the blood and Like if my entire face was covered in blood and I take a shot and just cover my face, and I have like an imprint of my face there with my blood stains in it. So that's kind of what it is. I haven't really gotten deep into the topic, to be honest, but apparently that shroud actually belonged to, Jesus Christ, and there's been some evidence that it probably does, but I'm not gonna get into that. I'm very neutral on that topic, but I don't know, apparently they use machine learning and deep learning to like uncover patterns and stuff to, aid it as evidence for the hypothesis that, it is really the face of Jesus that we're talking about here. But anyways, that's an example of approximating the past, right? So we can use deep learning for archaeological purposes. We can use deep learning for predicting the financial market. So that's predicting the future or approximating the future. So that's all prediction is. Moving on. Artificial intelligence is a machine that mimics human intelligence by approximating reality and making decisions from that approximation. That's all AI is. So we define what AI is, right? We define it over here. That which is probably not conscious, and thus mimicking the desire to expand its field of awareness, and seems to have the capacity to expand its fake field of awareness, is what we call artificial intelligence. And if we can simplify that definition into AI is just a machine that mimics human intelligence. And we know that what that prediction is approximating reality, so we can say that AI is just a machine that mimics human intelligence. How does it do it though? It does it by approximating reality, because that's all AI is. It's just a machine that is making predictions. Like if you're into data science, if you're into machine learning, you actually understand how these models work. You know that they're just statistical models. And statistical models are just models that are making predictions. ChatGPT is just making a prediction on what the next token it needs to output. In tokens, a token can be a word, a sentence, a period, a comma, in natural language. If you're building a machine learning model to predict the stock market, a machine learning model that predicts the stock market is not the same as a large language model like ChatGPT. So again, any trading videos out there that are like, oh, use ChatGPT to improve your trading game, that's nonsense. That's nonsense. Just no. Unless you're using like large language models to like retrieve news data, right, and use that news data to invest, that's fine. But these large language models are not predicting the financial markets unless you're using like forecasting or time series transformers, because that's the thing. These large language models are built on transformers, a transformers architecture. So you can adapt those transformers architecture for certain use cases. You can adapt it for computer vision, something known as vision transformers. And you can adapt them to also time series, I believe. But I don't know much about the time series aspect of it, to be honest. But I have worked with vision transformers. But that's another reason why you gotta like peel off the layer so you can learn how to cut the noise from a lot of, these buzzy words that are going on in social media. So artificial intelligence is just a machine that mimics human intelligence by approximating reality and makes decisions from that approximation. So you can prompt your AI model or machine learning model to make decisions from that prediction that it made. That is what you call an AI agent. If it makes decisions, it's an AI agent. Or when you automate it to do certain tasks, it's an AI agent. If it's just spitting out predictions, then it's not an AI agent. It's just a model that makes predictions that seem intelligent-like or human intelligent-like, that we'd like to label it as an AI. So if I create a simple linear regression model to predict house prices, for example, in a way you can call it an AI, but it's just a statistical model, a linear regression. If I use a neural network to classify an image, that seems very much like human intelligence, but it's still a statistical model. It's still a statistical model. It's just it's like a linear regression. It's just a very complicated linear regression. It's no longer a linear regression by definition. It's non-linear function that can predict something. In this case, classifies an image. And that in itself looks human-like, right? But it's just another statistical model. Now, if you prompt it to make a decision, so, okay, I predicted this is a cat, therefore I'm going to search the web for information related to cats. Now it's an agent, because now you give it the ability to make decisions. So there are two aspects that you need to understand in navigating this world of AI. You got your agents and you got your regular machine learning models, and that includes large language models. Large language models are not agents. They're just, again, very complicated statistical models. But when you give it the ability to make decisions, now you're diving deep into the world of AI agents. So before I continue getting excited about that, let's take it a step further. Everyone is approximating reality. So humans approximate reality, right? What do I mean by approximate reality? We're predicting or making our best guess relative to a specific situation. And we do this so that we can make a set of decisions in our lives. So everyone is doing this. AI just does it at scale. AI just does it, at scale, at a massive scale. So prediction is the goal. That's the goal. That's the game that we're playing. We're playing the game of prediction. That's all it is. So most people don't really understand the game that they're actually playing. This is the game they're playing. This right here. Yeah. This I got from another video. I do not remember the YouTube channel. I need to get that YouTube channel out there, and if you're watching this video, I'm probably gonna link it somewhere up here, because this is not my map again. This is not from Domain of Science. This is from this other YouTube channel that does statistics, and I'm so sorry I do not remember its name, but I'm going to I don't remember his name, but I'm gonna link it somewhere around the video. But I love this map because, again, I just love maps in general because it helps you visualize all the concepts in a particular field. But yeah, this is prediction. This is the game of AI that everyone is so hyped about. Not very sexy anymore, right? Unless you're like a nerd like me, right? So yeah, predicting is kind of hard. So statisticians, right, this is statistics, started taking some help from the automators, or the computer geeks, right? The computer scientists, basically. So remember automation, right? Making decisions from that approximation. So this is a way to approximate reality in a very rigorous way, right? Because human beings make predictions all the time, but through intuition, right? Like learning to walk is pure intuition. You have to first practice it until next thing you know, you develop this muscle memory, and now your brain is constantly predicting things that without you having to think about it consciously, if that makes any sense. But of course, you can formalize the idea of prediction through probability theory and statistics, which is hard. And you can write down and make calculations on paper, but that's very inefficient. So we want to create a machine that can do all those calculations for me, or these predictions for me. So if any of you have learned about the story of Alan Turing, so the man who cracked the Enigma code, right? He built this machine that can crack the Enigma code, because, I mean, technically you could crack the Enigma code, but it just took a lot of time. And the machine can do it a lot faster, so he built this machine that can do those calculations a lot faster. And that's all the automators did, right? The computer scientists, the computer geeks. So remember how we said that the goal was to predict in order to make a decision? Well, this is the field that does that. It's called computability theory, or the theory of computation. And that's when you get into nice, interesting stuff about Gödel's incompleteness theorem, mathematical logic, theory of computation, N equals NP, right, complexity theory and all that I'm going to be honest, I do not completely understand because I haven't, dived deep into that field. I just kind of like dabbled into it. But I will be diving into that field in the future. Right now I'm interested in AI at the moment. But that's very important concepts that's related to it. Oh, and by the way, this right here is the map of mathematics. Again, this is part of the YouTube channel Domain of Science. Highly recommended. I love maps. But anyways, how do we just piece all these things together? Well, you have to ask a couple of questions. What is your goal? In this game of prediction that we're dealing with, that's the game we're playing. Prediction. What is your goal? Is your goal rigor? Is it speed, or is it automation? What do I mean by rigor? If your goal is rigor, that is, I want to be I want to predict something. Remember, you're playing the game of prediction. So what is it that you want to predict? I want to predict the stock market. Yeah, that is a rigorous goal. Then it's basically you want to be very precise in your predictions. Otherwise, you're going to lose money. So your goal is rigor. You want to build very, very rigorous, heavy mathematical, quantitative models. This is why if you're going to, seek a job in the financial industry as a data scientist or as a quant, you call it a quant, you need to know your heavy math. Right? You can't just launch your ChatGPT and hey ChatGPT help me predict the stock market, or create an AI agent to predict the stock market, or create your little Python script, and trade forex. And no, like real hedge funds out there, they use rigorous models. They use the map that I just showed you, and even more complex stuff. This is nothing right here. They really focus on rigor. So on developing highly rigorous models, and then coding out those models to predict the financial markets, for example. If that's your goal, then AI is like, yes, that's AI. I mean, it's machine learning. That's what it is. And there's a difference. So machine learning is a machine that learns, right? It's you're basically, to understand machine learning, we have to understand the difference between explicit programming and implicit programming. So explicit programming, first of all, what is programming? So you got line by lines, right? It's a language that you tell the computer, or you're giving the computer instructions to carry out a specific outcome, right? Or to produce a specific outcome. Explicit programming, you're giving the computer very deterministic set of instructions that if it were to follow it, you would know the output of whatever it is that it's going to output. But implicit program, you don't know the output. You don't necessarily know what the computer is going to produce. You're giving us a set of instructions, but they're not explicit enough for you to actually know what the output is going to be. So there's like a nature of or an element of randomness to it, and that element of randomness is the pillar of all machine learning, and that's machine learning. So in statistics, right? I don't want to dive into linear regression at the moment, but the point is that is machine learning. Machine learning, we have a set of weights, right? A set of weights, and I promise I'll get into the math behind this later, like in the future, but we want to understand what are the different numbers for each of these weights, each of these functions. And to do that, we can't there is no deterministic way to do that. You have to experiment randomly, or quasi-randomly. There are methods to, there's a method to the randomness, if that even makes any sense. But I'm talking at a very high level here because I don't want to dive into the inner gritty details of it at the moment, because I don't want this video to get too long, and I just want you guys to have like a general idea. But that's rigor right there. That's rigor. Is your goal speed? Are the predictions that you want to make not so difficult, or maybe you don't care so much about the accuracy of your predictions or the precision of your predictions. You care more about your efficiency of your decisions, or the speed at which you predict, right? And you're okay with having some kind of error in your predictions, in which case you might want to get into data analytics, right? You want to get into business intelligence, for example, where speed is high priority. You just want to quickly look at your data, get whatever insights you want to get, visualize them, put them in Google Tableau or Power BI or Excel, and present it to your supervisor, for example. That's data analytics. You can use tools like SQL or SQL, whatever you're going to call it, Python, Excel, Power BI, Tableau, and you can provide some very interesting insights to an organization's data. Pretty self-explanatory. You can dive deep into that. Now, here is the part where all the hype begins. and that is automation. So, like I said before, is your goal, so this is actually also linked to like trading, by the way, because you can also create an algorithm, like a very rigorous mathematical framework, and then you can automate that framework, so you build like an algorithm that is trading in the financial markets, right? The trading bots, for example, or algorithmic trading, as they like to call it. So that's also part of automation. But apart from the financial markets, we can build machine learning models that are automated to carry out specific tasks, and we can call these agents. Now, apart from large language models like ChatGPT, for example, when ChatGPT came out, it wasn't an agent. It was just another machine learning model, a very complex and useful machine learning model. But it was just a statistical model, a very specific statistical model known as a transformer. A transformer, without getting deep into it, is just a set of neural networks and a specific block known as an attention block. That attention block right there was the key for the transformer. But I'm not gonna get into that. But that entire architecture, that is a statistical model. And the interface that you saw, that's just pure software engineering and design. But all it's doing, you're feeding it a bunch of data, text data, and it's outputting a specific output based on the input that you give it. That's all it is. So it's a statistical model, basically. So like, I give it a piece of data, and based on the data you give it, it outputs something. That's a basic machine learning model, or the concept behind a basic machine learning model. Now ChatGPT nowadays ChatGPT, if you're watching this in 2025, is definitely an agent now, because now ChatGPT can do more things like search the web, or specifically if you're working with more advanced models like the O1 model, for example, or even more advanced models that can, depending on which platform you're working with. But the idea is that you're giving this large language model tools. You're giving it tools, basically, in an environment to execute code. So now it can actually do tasks. You're automating it to do specific tasks, and that, my friend, is called AI agents. So you just have to ask yourself, what is the goal? Because I know some of you are probably seeing all these videos out there. There's like data science videos. Okay, so data science has something to do with AI, and AI has something to do with machine learning, and machine learning is also data science. They all the same. Like, what is going on here? There's this guy telling me over here to get into AI agents. There's this guy over here telling me to get into AI engineering. There's this guy over here telling me to get into new age machine learning. What the heck? So this hopefully this helps in navigate all the noise that's out there. That's really all it is. It's just rigor, speed, or automation. Now, three main things that all of these have in common is the data science process. So all of these things begin with data science. And the data science process is just this, right? You define your problem, the thing that you want to predict, because remember, it's a prediction game, right? You collect your data, you prepare your data, you clean your data, you pre-process that data. And that's often the part that just takes a lot of time, really. And then you do an analysis of the data so you can get a feel for your data and maybe extract some very interesting insights. That's a part that a lot of people like to skip. And then you maybe want to engineer your data a little bit, right? The features of your data. And then you want to get into the modeling. Then that's when you do research on different machine learning models for a specific use case. And then you want to measure your model. You want to evaluate it. And then you deploy it for whatever purpose you want it to deploy it for. Maybe for prediction purposes, for super fast analytics purposes, or maybe for an automation project, like building an LLM application, which is what I personally want to get into. And of course, there's a maintenance and communication business side of it, but they all follow the same data science process. Now, out of these three things, we get the different AI/ML roles. This chart right here I got from Code Basics, another excellent YouTube channel. I'm gonna link all these channels out here. Hopefully I don't get in trouble from YouTube, because I'm linking out my sources. I don't know, YouTube is weird sometimes, but whatever. You live and you learn. So if I do get blocks, whatever, I don't care. I'll just make another video or change it, whatever. These are the different AI roles, and I love this chart because it's a good visualization. Like, you got your technical AI roles and you got your non-technical AI roles, and that's very important too, right? We don't just want to talk about the technical side of things, because remember, we talked about how there is something known as, there's something known as the how of AI, right? The technical aspect of it. We also have to deal with like the what of AI and the philosophical aspects of AI as well. And you can also become like an AI ethicist or an AI philosopher, right? I think AI philosopher just sounds cool. So you want to get into a bunch of things like business communication, ethical reasoning. I would add to that philosophical reasoning, right? Read books like Life 3.0 by Max Tegmark, like all these things, you know, you like really dive deep into the philosophy of these things and communication, start a YouTube channel, maybe like start a blog, whatever. Sales, get into sales. Learning business concepts, learning certain CRM tools, you know, it's all in here. AI product manager, and then of course there's the technical aspects of it. So you can see a data scientist would have, so all these guys have a lot of these tools in common. Just some tools have a higher priority than for some roles. So some roles have a high priority for certain tools than other roles, for example. So there's not much for me to say here. You can probably check this video out, but you can take a look at these, just read the charts. It's pretty self-explanatory, nothing really to add here. So we got your ML ops engineer. A lot of these fields tend to intersect, especially when you're building an LLM application. So that's something I've noticed. Had to do a quick pause right there. Anyways, moving on. I'll probably edit that out or something. I don't know, we'll see. Moving on. Yeah, this is like, if you just take a look at this, all of them more or less have like the same, they have a lot of tools in common that they use, right? And the same core aspects that you would need to learn for learning these specific roles that you're getting into. But here's the thing, I wouldn't approach learning in this way, like, oh, okay, I want to be a data scientist, so let me just learn these tools. No, I wouldn't approach it that way. This map right here is good to like visualize and get a feel for the different types of AI related roles that are out there. Because for example, if you want to get into like, you know, the rigor side of things, and maybe specifically in the financial markets, then obviously you would get into like data science, but for the financial markets specifically. And then you might even realize that, heck, maybe that within the financial markets there are other roles out there in the rigor game, right? There's not just the data scientist, there's also the quant. And you also, you know, if you watch people like Dimitri Dibanco, I think that's his name. I'm terrible at pronouncing names, but he has a YouTube channel, very good quant YouTube channel that he even goes deeper into this, into different, you know, quant related roles. There's another channel called The Coding Jesus, for example. Those are probably the only channels I would recommend when it comes to like the financial markets and trading in the quantitative side of things, at least. But these go deeper into the different roles in those areas, in that game, right? So there are games within games. So that's the whole field of prediction, but in relation to rigor, right? So that's an entire other field that you can like dive into. And then obviously the other fields I would consider more like towards the software engineer side of things. So like the NLP engineer, AI engineer, computer vision engineer, ML ops engineer. All of these are related to software engineering, right? And in software engineering, you got your full stack, right? You got your front-end developers, your back-end developer, your DevOps. So, and they're all working together, designers. So that's more of like the builders, right? Or as we talked about, the automators, the automation aspect of the game of AI. And of course, speed, we have to introduce speed, right? It's not here in the charts, but it's also related to data science, but a specific subfield of data science called data analytics, where you got your data visualization tools and you're focusing more on providing meaningful, quick, intelligent insights to businesses. So that's how I would visualize things, or visualize the different players of the game of AI. But like I said, this is not how I would approach learning AI. Here's how I would approach learning. First of all, you have to ask yourself, what is the infinite game that you want to play? What's the infinite game that you want to play? Now, what do I mean by infinite game? I learned this from Alex Ramosi, and he said that, so here's the thing. I also talked about this in one of my previous videos on how I would learn AI in 2025. I'd highly recommend you check that video out, because that's where I talk about how I'd actually learn AI in playing this game. Many people ask the questions like, how many projects do I have to build? How many lines of code do I need to write to become this good? If you think in that mindset, I'm sorry, man, but you're already lost. Now, I say this with deep empathy, because I also used to think in this way as well. But you don't want to think in terms of like, I want to achieve this specific outcome. No, you want to be passionate about the game itself. You want to make it so that you just don't want to stop playing the game. Like, that's the end goal. The end goal is for you to not want to stop playing the game altogether. If you stop playing the game, then you lose. But if you don't stop playing the game, then you already won. You already achieved the main goal that you wanted to achieve, is you playing the game in the first place. And how far that mindset will take you much further out than having don't get me wrong, having some milestones, having goals is good as a way to like having some kind of roadmap or direction. But remember, don't do this as a means to an end, right? Or I just want to get rich or make money. If that's what you want to do, I mean, whatever. But like, if you want to become like really good or one of the best in the field, then this is the mindset you need to start to training your brain around, right? Your psychology around, is this an infinite game that I want to play? Is this a game that I want to get into that I just don't want to stop playing? Like, that's my end goal. My end goal is to not stop playing this game. So the question is, what infinite game do you want to play? So you want to play the infinite game of AI. If you're sure about that, ask yourself, okay, what infinite game do I want to play? The game of rigor, the game of speed, the game of automation? Think about it in chess. Chess is a game, but there's also speed chess, right? If you look at those competitions in chess, how, every single second they have to move the chess pieces around, and then you compare that to the more traditional style of chess, where these grandmasters are just taking hours to make a move. That's kind of how I would analogize the different aspects of the game of AI, right? So speed, that's speed chess. Rigor, you got your, the grandmasters are just taking their time and making a move. And I cannot think of an analogy for automation. Or creating AIs that are playing chess with each other is probably the best analogy for automation, right? And AI agents. So what infinite game do you want to play? So here is another good chart from Code Basics that kind of helps you guide, that gives you a proper guide to how to choose these AI related roles. So I like this guide. I'm going to show you an even more simplified yet practical way to approach this as well, but this I find pretty useful. So this is more of an interest/skills approach to choosing the game that you want to play. So are you good or have an interest in mathematics or statistics? If the answer is no, then become an ML ops engineer. And with this, in this particular field, you're going to be doing a lot of DevOps work. You're going to be working with a lot of CIs, CD pipelines, right? Continuous integration, continuous deployment, man, I cannot pronounce it. Pipelines. You're going to be working with a lot of APIs, cloud services like AWS, Azure, Google Cloud, learning how these different cloud services work so that you can deploy scalable applications, LLM or AI applications specifically. and learning the code, the different ML frameworks, like the code behind a lot of AI related frameworks. Like if you're getting into like, especially in the field of AI agents, there are different agentic frameworks out there as well. So yeah, that's, if you're like not really interested in math, then that's a pretty good path. If you do have an interest in math or want to improve your mathematics or are good in mathematics, then ask yourself the next question: how do you rate your computer engineering skills, right? Are they strong? Are they average? If your computer engineering skills, I would also specifically say computer science skills, not just computer engineering skills, computer science skills. Then if it's just average, or you're not really that interested in like data structure and how, like, if you're not that so interested in like diving deep into in code and learning different programming languages and really getting your hands dirty with software engineering and all that, then I would probably replace this computer engineering with more like software engineering if I created this map. But anyways, how would you rate your computer engineering skills or your software engineering skills? If they're average, then data science. So this is where I am at currently. I am mainly a data scientist. So I have a deep interest in mathematics and statistics, and I have some coding, like I have coding skills obviously as a data scientist, but I don't have it at the same level as a software engineer. So that's where I'm currently at, but I do have an interest in improving my skills. So I have a strong interest in the field of AI engineering. That's what the role that I want to, that's the infinite game that I want to get into, basically. And then of course within AI engineering you have other subfields, right? You got natural language processing, and then you got computer vision. I lean towards more natural language processing at the moment for the current projects that I am working on at the moment. So NLP engineering. So this is a good way to navigate it. You also got your people who are not so technical, right? You got your product management, sales, ethicist, philosopher. This is a good starting point that you could use to guide yourself in the noise, right? Now here's a very unique way that I like to approach these things. Now, mind you, if your goal is not to be a data scientist or anything related to rigor, and it's related mainly to like automation, building things, that is engineering. So if it's not related to rigor or data analytics and all that, and you're mainly interested in like automation, or you're interested in getting into what I'm getting into, which is basically combining data science with software engineering, that is AI engineering. That's the game that I'm personally going to be playing for now, because I want to learn everything, right? If you know me, if you know this YouTube channel and what we're all about, we want to become a polymath, we want to become a digital renaissance man. And basically it's the idea that we just want to learn how to effectively learn everything, basically. And I have noticed an interesting trend. Anyone that's like interested in computer science, a lot of people that are interested in computer science are natural polymaths. That is an individual that is interested in learning a lot of things. And that makes sense because computer science is not an isolated field. It's a field that combines many other fields. It combines mathematics, it combines physics, it combines electrical engineering, it combines algorithms, it combines so many things. So obviously people that are interested in like these kind of things are by nature people that like to tinker with stuff, and people that like to tinker with stuff by nature have this very divergent mindset, and that's why I found this trend where there's a lot of computer science people that are polymaths by nature, including myself. So if you're interested in playing the game of AI engineering, the game that I am going to be playing personally, then this is how I approach learning AI engineering. So I already went deep into this in my previous video, you can check it out. But just to like reiterate what I was talking about, first of all, first principles experimental learning. Now, if you watch my second video on how to think, you kind of have an idea of what I'm getting at. We got it all backwards. Everyone online is teaching you what tools to learn. So everyone is telling you, okay, if you want to be a data scientist or an AI engineer, these are the tools that you have to learn. And yes, these are the tools that you have to learn. But no, don't learn them like that. Don't go and take a 30-hour course on Python, then a 30-hour course on SQL, then a 30-hour course on pandas and exploratory data analysis, and then a 30-hour course on machine learning and deep learning, and another 30 hours. No, don't do that. That's not very efficient. You will learn a lot of theory doing that, but that's the thing. You're going to be learning theory. If your goal is to become an AI engineer, you become what you do, right? So to become an AI engineer, you got to do what an AI engineer does. And an engineer, by definition, builds solutions. So you need to build stuff related to AI. So are you building anything by watching these videos? 30-hour videos and courses and just taking notes? No, you're not building anything. You're getting a deeper understanding, yes, but unless your goal is to get into the game of rigor, then studying theoretical concepts is not going to be very practical unless, again, your goal is to get into the game of rigor. That's why I presented these other paths you can take, right? But if your goal is to get into engineering, then you need to adopt a different mindset. You need to adopt a mindset of experimentation, right? Or what I like to call in my second video, experimental learning, right? And you have to get used to the concept of first principles thinking. So we're not just tinkering with a bunch of tools and experimenting and putting it into practice and actually trying to build something useful. We also have to do it systematically. And that is how first principles thinking does. It helps us systematically break things down into its fundamental components. This is the exact same mindset that Elon Musk has when he built SpaceX or Tesla. And this first principles thinking was not introduced by Elon Musk. It was originally introduced by Aristotle. And he was an amazing experimental first principles thinker. But again, you can check out the second video out from this YouTube channel called How to Think, or a guide to mental models I think it's called 4 mental models for 2025. So it's not about the tools, it's about the objective, and from the objective we derive the right tools. So instead of looking up, okay, how to learn Python, and stumbling into a 30-hour video in Python, don't waste your time. Instead, ask yourself what you want to build. Say I want to build an LLM application that I want to build an AI chatbot using, OpenAI's API, for example, or an open source model, whatever. You learn those concepts as you experiment and iterate. Instead of searching how to learn Python, SQL, and all that, learn how to build an LLM application. That is much more specific and much better. I'm not saying don't watch videos or don't read books. I'm saying that the content you're consuming needs to be more fine-tuned. No pun intended, right? It needs to be, it just needs to be more specific. How to build an LLM application, how to build a full stack AI application, right? Heck, even use ChatGPT to help you build these mind maps, for example, or get a general idea, for example. So that is going to be much more practical. That is what I'm personally doing when it comes to learning AI engineering as a data scientist. So yeah, it's been a lot in this video, but I feel like that really covers a lot of the noise that is out there. So as soon as you define an objective, then you can derive the tools. Of course, now you actually have to think, right? This is why people love courses, because courses don't really make you think. You just have to mindlessly download extract all the information, unless your goal is to learn theoretical information. If you want to do research, for example, like machine learning research or computer science research, or getting into quantitative financial markets, right? That's different. Again, what is the game that you want to play? What is the infinite game that you want to play? So if you want to play the game of building AI engineering, this is the mindset that you need to adopt. This is the mindset that I'm adopting in 2025 to learn AI engineering. That way I don't go out and read 25, 100 books on AI engineering. No, I actually go out there and build stuff on AI engineering, getting my hands dirty. From the objective, we derive the tools. Now, how do I know what I want to build? Well, personally, you can build anything you want. Just have this Mamba mentality, right? If you guys know Kobe Bryant, search up Mamba mentality. Just have this aggressive mentality to just start, right? Get out of that paralysis analysis. The man or the woman who is actually powerful, the individual that is actually powerful, is the individual that is able to shorten the time between an idea and the execution of an idea. Because we take forever to execute an idea. But the less time it takes for us to actually execute an idea, the more powerful we become. Now, the way I like to approach it is determining my vision. Alright, so funny story. So this is video editor mode, Tony, and I literally just realized that I totally forgot to record a conclusion. So I have that habit. But anyways, here I am. If you notice that I have a haircut, it's because yes, I did get a haircut. It's funny how video editing works. It's been a couple of weeks. With that being said, I hope you guys enjoyed this video. Hope you got a lot of value from it. The idea of this video was to not so much create a roadmap per se, but more of a guide. A framework that we as developers or anyone really can use to really think through all these technologies and frameworks and coding languages that there are. This is why I didn't create a video specifically on technologies or programming languages to learn and how to do that and resources to carry that out, but rather just a guide to really understand, okay, why am I doing what I'm doing and what is the game that we're actually playing? What is the role that I actually want to tackle? I will in the future though be diving into more of like the hardcore types of technologies and programming languages that there are out there, and more of a hands-on tutorials on how to actually do that. But this is very crucial because here's the thing: I could create the perfect roadmap for 2025, but then what about for the next year, and then the year after that, and the year after that? And my goal is for people to cut the friction, like just to completely remove all the friction as much as possible and just get straight on to developing stuff, because that's the way that we're going to be learning. It's not about gathering and reading 10 books, it's about actually getting to, building stuff, building applications with AI, or building AI applications. And that's kind of what I'm doing. I'm also learning, I'm sharing my journey in learning, and I just really hope you guys got value from that. If there are any suggestions, video suggestions, any questions, let me know. So if you enjoyed the video, give it a thumbs up, subscribe, and see you in the next one. Done.